Hey, before we go on to standard deviation, I'd like to show you how to make a box plot, as we ended with in the last part of the lecture, by going to Stat Crunch. So I'm here, and you see modules has been cut off some, but it's already set up to load my Stat Lab. Stat Crunch in a new window. So to do that, I'm going to pick a data set from my textbook just to show you how to do it. And I'm going to come down and I'm going to pick Florida Student Survey. It loads the data, and this time I'm going to graph the box plot. So there's the pie charts, etc. Histogram. Here's the box plot. I'm going to pick age. Could have picked something else. And down here I'm going to say to the boxes horizontally. And compute. It's done. The box over so you can see it thoroughly. This is the lower limit. This is the upper limit. This is Q3. This is Q1, and there's the median. Now, how do I get this upper limit? You see these points here are actually in the data set, but these are outliers. To get this upper limit, I take the Q3 minus Q1 to get the interquartile range, which is 7. And I take 1.5 times that 7, that gives me 10.5. And I add it to Q3, that's 41.5. And I round it to 41. Anything to the right of that's an outlier. I could do this on the left, and this time I'd be taking a 10.5, subtract it from Q1. It turns out there's nothing to the left of that. So these endpoints here are only endpoints in the sense of limiting what we consider to be relevant in our range. So let's go back to the lecture and go to standard deviation. S sub x, usually referred to just as S. You might see S sub n or S sub n minus 1. And this is the standard deviation of the sample. To find it, you take the difference between x bar, the sample mean, and each data point, and you square it. And then you add all those together. You divide not by n, but by n minus 1. And here's a compressed way of showing it. And that's called the variance. That's why you see the squaring. Now, that variance is okay, but the standard deviation is when you take the square root of it. And it's shown here slightly a different way, with the square root symbol above it. And this gives you some idea of the distance of each point from the sample mean. So we're giving this data in a dot plot. It says calculate the mean, each deviation, that's the observation from the mean. And they give you enough numbers there to where you can calculate this. Show you the deviation. And then they show you that squared. And they say, what's the sum each time? You can pause this and look at it better. So the average squared deviation is what we actually found, is 6.5. That's the variance. But remember, the square root of that is the standard deviation. So we're using calculators to do this. And I'm going to challenge you to use your calculator, see if you can do it, especially TI 83 or 84. Maybe you're not used to what buttons to press, so you should stop and check that. So S is the sample variation that you've taken and found the average of. So you should only do this when you're working with the mean. If the standard deviation, S, of the sample is 0, that means all the observations, all the numbers are exactly the same. Otherwise, it's got to be bigger than 0. It's not resistant to outliers. That means if you get a really big number or a really small number compared to the others in there, it will change quite a bit. It has the same units of measurement as the original. So if we're talking about the number of minutes to get to work, and it asks you what the standard deviation is, and the answer is 10, you should say 10 minutes. You need to put the units on to get full credit. Choosing measures of center and spread. So you have the mean and the standard deviation, you have the median and interquartile range. Standard deviation goes with the mean, interquartile range goes with the median. So if it's a skewed distribution, the median works better. If it's pretty symmetric, it doesn't really have outliers, or not many, you can be looking at the mean and standard deviation instead. Now you always need to plot this data, some type of graph, etc., because that will actually show us what's going on. We're going to stop her here.